Chapter 10, Computer Output and Re-expression. In this section, we are going to go back to this computer output that we saw in Chapter 8 and talk about how to use that computer output along with this idea of re-expressing our data. So in our first example, it says during a science lab, students heated water, allowed it to cool, and recorded the temperature over time. They computed the difference between the water temperature and the room temperature. In hopes to use time and minutes to predict the difference in temperatures in degrees, they created several models. In my first example here, mine printed funny. I'm not sure if yours looks like that as well. If so, go ahead and sketch the scatter plot and residual plot off to the side here. The scatter plot is decreasing, but it is making quite a curve. And the residual plot gives me a definite pattern. It's almost looking like a parabola. So what's tricky about these is that at first glance, it's kind of hard to tell what the different re-expressions are. So model 1 is giving you just time versus difference in temperature. This means that this is our raw data. They should give you a scatter plot, a residual plot, and then your computer output. Remember, with this computer output, there are two important things that we are looking for. The first, or one of them, is our y-intercept. Your y-intercept is always next to the constant. So this 66 is my y-intercept. The slope will also be in that column. The slope is always next to the variable, the x variable. So in this case, the negative 1.2 is my slope. They will give you some things that we don't need, like the standard error and t-ratio. Right now, we don't need. Sometimes they'll also give you r squared, so make sure you can find r squared. Sometimes it just says r squared, or it might say r sq, that means r squared. Alright, now in model 2, I'm noticing that my slope and y-intercept have changed a little bit here, and that's because the model has changed. In model 2, we are looking at time, so they kept the x variable the same, but now they're looking at the reciprocal of y. So this was 1 over the y value. Again, I'm noticing my scatter plot is still a little bit curved. It has changed directions. Now it's going in a positive direction, but the scatter plot is still showing a pattern. Model 3, they left the x variable the same, but this time they took the log of y. Scatter plot looks pretty straight this time, and my residual plot still somewhat shows a pattern, but it's a little bit less of a pattern than I noticed in the other two. So in part A, it says, which of the models above is most appropriate to use? We want to explain our answer here. When identifying which model is most appropriate, we really want to focus on the residual plots. So I'm going to say that model 3 is most appropriate because its residual plot had less of a pattern than the other two. So model 3 is most appropriate because its residual plot has the least pattern, or you also could say is the most random. I have a few things about this appropriateness. Oftentimes, none of the residual plots are going to be nice. None of them are going to be perfect. I'm not loving this residual plot. I still think there's somewhat of a pattern, but there's less of a pattern than the other two, so this is the most appropriate. Is it absolutely 100% maybe the best choice? Out of these three, yes, but out of all of them, maybe not. Maybe there is another one out there that would give me a very random residual plot. Please, when you're talking about appropriateness, do not talk about the scatter plot itself. Yes, I know that this scatter plot is straight, but we should be using a residual plot to determine whether or not a linear model is appropriate. Okay, part B says write the equation for the regression line based on your answer in part A. So we said that model 3 was most appropriate, so I'm going to be using model 3 to write this equation. So I need my y-intercept and my slope. When you go to write this, make sure you are again using the correct re-expression. So I have log of difference in temps, and this should have a hat on it because those are predictions. I'm going to put my y-intercept first, and then my slope, and the slope is being multiplied by the x variable. You can look up here for this x, or you can look in your computer output. This gives me time. Part C said, do you feel confident of the predictions that this model will provide? Explain. Now, ideally, I would like to have an r squared or an r value to answer this. Since I don't, I can talk about the residual plot. The residual plot is random. It's not the most random, but it is random, and the scatter plot is quite straight. So I'm going to say that I feel somewhat confident of these predictions. I'm saying because the scatter plot is straight and the residual plot is random. It would be best to talk about the r squared and the r value here, but because we don't have that, it's okay to base your answer based on the scatter plot and the residual plot. Okay, go ahead and pause your video. I want you guys to try example 2. Once you're done, go ahead and play and you can check your answers. Here are my answers for number 2. In part A, it was looking at the r squared value, and you needed to determine if this r squared suggested that this was a good model. I said yes because this means that 97.2% of the variation in GDP is accounted for by the variation in year. That's quite high. It's very close to 100%, but we should make a residual plot to check. In part B, they made a residual plot. They called it a scatter plot of the residuals, which is just a residual plot. Now, do we think this is a good model? No, it should be a definite no. There is a very clear pattern in that residual plot. Part C says, here's a regression and a residual plot using the log of GDP. So they logged the y variable. Is this a better fit? This is definitely better. One, your r squared is higher, and now there is less of a pattern in your residual plot. Is it perfect? No, because there's still somewhat a pattern, but generally speaking, I'd say that this is slightly better because there's less of a pattern. On the next page, they give us 2 examples. They give us the data, and we are asked to create 3 models to predict the number of ornaments from tree height. We want to sketch a scatter plot for each of them and a residual plot, then explain which model is better. So we are kind of coming up with these 3 models just on our own. My recommendation, just pick 2 random ones. It doesn't matter if they're very good fits, but you do want one of the models to be a little bit better find a model that makes your scatter plot straight. So we're going to go to our calculator. I'm going to stat edit. I'm going to clear out all of this old data. And I'm typing in tree height in my L1 and number of ornaments in my L2. Okay, let's go ahead and look at the scatter plot for just our raw data. So here's our raw data. It doesn't look perfectly straight. It doesn't look crazy curved though either. So I'm going to use this as one of my models. So I'm just going to call this raw data. We need the scatter plot. We didn't change anything, so I'm going to leave this as tree height and number of ornaments. Just going to sketch what's happening. And I also need to make sure I have a residual plot here. Now this part is kind of tricky. In order to create a residual plot, so let's just say right now I wanted to create a residual plot. If I go to my stat plot and I change my Y list, I want this to be residual, so I'm going to hit second stat for list. This residual is not going to be correct because I have not created a line of best fit yet. I have to create that line of best fit before making a residual plot. So we have to go to stat calculate, linear regression, pulling data from L1, L2. I don't need to write this down for this one because it's just telling me to sketch each scatter plot. So you could write down the line of best fit if you wanted to. You need to calculate it in order to come up with a residual. Now I can go to my stat plot, and when I go to second stat, this residual is now correct, so I can zoom 9. So my raw data did look somewhat straight in that scatter plot, but my residual plot is giving me some definite concerns. It does look like there is a little bit of a pattern going on here. So we are going to create 2 more models, and hopefully one of them has a better residual plot. So I'm going to go to stat edit, and I'm just going to start working down my ladder of powers. I like to start with square rooting. So I'm going to square root L2, going back to my stat plot, changing this to L2, I'm sorry, L3, zoom 9. I am thinking it's a little bit better, so I'm going to write this one down. This one I didn't change my x variable, so this was still tree height, but now instead of just the number of ornaments, we were taking the square root of ornaments. It looks like this. So a little bit straighter this time. I do want that residual plot to see if it's any better. Again, before I make the residual, I do need to run my linear regression. I'm now pulling data from L1 and L3. Now I can go to my stat plot, change this to residual. So although my scatter plot looked a little bit more straight, my residual plot is still giving me some patterns. So hopefully I can find another model that's a little bit better. It's not a terrible residual plot, but I'd like it to be a little bit stronger. I'm going back to my stat. We just tried the square root. So next on my list would be my log. Going to my stat plot. Okay, before I jot this one down, because I'm out of space, and I can always go back here, I'm just going to check this residual plot to see if it's even a good fit before I write it down. So I'm going to do my stat calculate linear regression, pulling data from L1, L3, and L3 now I have the log of my y variable. Again, changing this to residual. My residual plot's looking slightly more random there, so I might consider doing the log of L2. That one was a little bit better. For the sake of this example, I'm going to keep looking. After log, my next option is to do 1 over the square root. So I'm doing 1 over the square root of L2. That one did change the direction, but it looks very straight as well. Let's go ahead and run my linear regression so I can make a residual plot. A lot of calculator work here, but a lot of it is repetitive, which is kind of nice. I like that residual plot a lot better than the other ones. It is looking, I think, the most random that we've seen so far. So I'm going to use this one as my third model. So I'm sketching this residual plot. I'm going to go back here and recreate the scatter plot for this data. Again, we did not change our x variable, so we left this as tree height. And this time I logged the ornaments. The last thing that it wants me to do is explain which model is better. I ran out of room, so I'll just talk through it. Hopefully you have somewhere you can fit this on your paper. I would say that my third model here is the most appropriate because the residual plot is the most random. Is it a perfect fit? No, definitely not, but the residual plot shows the least amount of pattern. Go ahead and try example 4, looking again for the best model possible, but again, you're creating 3 models, sketching the scatter plot and the residual plot. Once you've tried the example, go ahead and play the video. I will show you 3 models that I've created, and then you can kind of compare that to the 3 that you chose. Here are the 3 models that I came up with. I just did the raw data, the square root, and the log. I found that the log was the best model because that residual plot was the most random compared to the other 2. You definitely didn't need to have these 3. You could have had anything else that we talked about on the ladder. So you could have done the reciprocal, you could have done 1 over the square root, you could have squared your values, or you could have done any combination of the logs.